Okay, so it doesn't look like anybody put anything in the agenda for today so far. As a matter of fact, give me a second. That's the agenda doc. Just posted it in the chat. So does anyone have any topics that we'd like to discuss for today?
I had a question. So the idea was for kind of initially to start off for different groups to kind of show or demonstrate what their current machine learning, pain points are for running on Kubernetes. And is that still of interest to people, or it seems like nobody's willing to step up at this point?
And I've been still collecting information from some of our users. I work for the University of Michigan, and a lot of our researchers have not been timely in responding to me. The students have been pretty responsive, but not so much the researchers themselves.
Not shocked.
Neither am I. So, and if you want, I can comment a little bit on like what the students have said and some of like our experiences as like sort of the research support staff. Otherwise, I can hold off till I get a little bit more information.
I mean, I feel like the input from the students would be valuable, maybe not as valuable as the faculty, but education in machine learning is a huge use case for it, right? Like, I mean, machine learning practitioners, researchers, data scientists don't grow on trees. They generally go to school somewhere. So, I mean, if we want Kubernetes kind of to be adopted in the community, not just for production use, but for educational use, the friction of students as they try to go through their workflow in order to get through class or to perform research of their own, that's valuable.
Well, and the students are the ones doing most of the work often anyway, so
Yep.
They would do the best to know the pain points.
Yeah, I mean, that was grad school for me at least, but.
Yeah, we're actually finding that it tends to be the students that are bringing this stuff to the researchers themselves, Kubernetes, containerization, and things of that nature.
Yeah, I mean, your advisor's probably not going to care what tool you use as long as the paper comes out the other end.
Yeah. Well, I guess like the quick thing, a lot of them tend to be like very overwhelmed with all the information out there. There's also like a lot of tutorials that just sort of like cover the very few basics, but nothing beyond sort of just getting started. They've had, enough to just get something up and going and sort of like a hello world type thing, but actually trying to take that beyond that has been a bit of a pain point. That also holds true for a lot of the like machine learning like libraries and things. It's not just related to getting up and going on Kubernetes. There's a lot of like if they're searching out like blog posts or other things like that, tends to be like a lot of just intro getting started stuff. In some cases, a lot of the documentation will actually like go against other documentation that they've found. So just finding like useful resources was something that was pretty universally commented upon. The other big thing, like the majority of students were also like very eager to like dive in to learn this stuff. That doesn't surprise me too much. A smaller portion of them were just wanting to sort of like continue going with sort of what they know already. The other thing, like for us, Kubernetes is still fairly small. Mostly lots of experience with our students in like Jupyter Hub and things of that nature and getting up and going on there. But our shop is still like a very classic big HPC group. So some of the container experiences they're getting like using Singularity and all that to run that through Slurm on our HPC. But that like, again, of the students and things like that, they would much prefer to use Kubernetes, use containers, use Jupyter Hub, and get going on there rather than try and pass something through a batch processing system, especially when it comes to like parameter optimization and all the other fun things.
So what hardware are they running these Kubernetes clusters on? Is it like cloud-based or what?
Well, we have an like on-prem virtualization thing. We run it on there. Some do use like GKE, and we are expanding Kubernetes out to bare metal.
Okay.
For on-prem. Us sort of as like research support staff, we honestly want to sort of have Kubernetes take over a lot of this space, just because like the massive growth of things like Jupyter Hub and more things that are not your classic batch scheduler. So like us as research support staff, if like we can sort of, have Kubernetes as like the unified platform that things sit on, and then if we want to spin up Slurm or something like that, that can just be like a namespace or something like that in there. But it allows us to make better, usage of our resources as things sort of shift in these different directions.
Have you looked at running Slurm type systems on Kubernetes?
Yep.
Our experience is it's typically trying to fit kind of round peg and square holes.
It
a lot
is.
of feature set is kind of needed.
We looked at trying to do Slurm, and we also looked at trying to do MPI type frameworks inside of Kubernetes, and
it's definitely a pain, but like we are making progress with it. We have like basically a proof of concept thing that will like user SSHs in and it spawns a container as their UID GID, mounts their home directory, and does all that. It is a little bit of a challenge to like, as a campus, we have all these central resources with, big shared storage and, all the other fun things, a big scratch disk. So getting like all that stuff like mapped in has been a little bit of a challenge, but we're working through it.
Cool. Okay. So Vish and I were doing some discussion, or had some discussion about potentially trying to improve, not for everything, but some of the documentation surrounding the Google ML products and some of the examples there. And by products, I don't mean our actual products. I mean like the open source stuff that we do, like TensorFlow, for instance, Kubeflow, and just trying to come up with some, onboarding and best practices that generally pertain to running machine learning workloads on top of Kubernetes. And maybe trying to aggregate some of the general limitations that were discussed last time. Like, depending on what you actually do and what your storage and networking situation looks like, we really don't have a lot of good answers around high performance networking and storage solutions directly integrated with Kubernetes. But at least we could capture the state of the art in terms of what you could do, what is available. Like if you did want to run some type of batch machine learning workload across HDFS partitions, that is feasible. It's just probably not such a great idea to try to run your HDFS cluster inside of Kubernetes. But you could do things like co-locating the Kubernetes cluster with the HDFS cluster in the same physicals, but have them logically partitioned. So things of that nature.
So within, hi, it's Jeremy from Kubeflow. So I think within Kubeflow, we're trying to solve a lot of those problems. I mean, I think a lot of the issues you just mentioned are coming up, and so we have sort of these open issues to sort of provide recommendations about how you deploy Kubernetes in various settings, various cloud providers, various Kubernetes distributions to sort of get the things you need. And so some of the issues that have come up so far are secure ingress. We've also got an issue about storage and how you do things, get common like object stores, shared files, POSIX compliant file systems. We haven't specifically looked at other high performance networking yet. I think one of the big ones for us next is things like monitoring, and especially with integration with like Istio, and also monitoring for things like RPC metrics and latency with respect to your model servers. And so any guidance or help with that would be amazing.
But you're talking about metrics for TF serving, correct?
TF serving is a big one, but we have other model servers that aren't TF serving. So we use Selden for non-TensorFlow models like XGBoost and sklearn models.
Okay.
And so like one of the questions.
Huh. Interesting.
I think he dropped.
Yeah, I think we lost him. So, okay. You can give him a moment to come back, but does anyone else want to bring any topics up in the interim?
I think one of the ARs from last time was to propose a new repo, and I forget if it was cube incubating and then have Vish approve that for kind of just starting to collect these, kind of getting started documents, or just a kind of initial nucleation site for
So
documentation.
Don't want to do that. If we want to, I talked with Vish about this. If we are going to do that, we have. So inside of inside of the working group and community, we have machine learning repo, basically. Right? So anything that we want to collect in terms of documentation, that would probably be the best place to put it, just because of the kind of rules around what's a SIG and what's a working group. So if we want to start owning code, we got to form a SIG, basically. Because working groups aren't supposed to own code, or we get another SIG to own the code for us.
Okay. Yeah, I don't think it really matters as much where it is. It's just getting somewhere and then having that, and we can start banging on it.
What was this code for?
No code.
This is documentation.
Documentation. Okay.
Give me 1 second. I'll just pull up the location, because you can do pulls against this now, immediately.
Because I think that's the lowest hanging fruit in terms of just getting started and addressing a lot of the points that Bob pointed out just now, and things we've seen ourselves, and then all of the harder problems that we definitely want to get to as well, like Jeremy was talking about. Then those can happen in kind of this points kind of to those, right? And this is the kind of the landing zone or entry point to those.
Yep. So I just linked in the location of, for anyone who's not aware of it, the ML working group. So we can put whatever documents we want in this subdirectory in the community to capture all of this. And according to the steering committee, that's the appropriate place. So we can do that. Or, if people prefer to use Google Docs, that's also another option. And we could just link out to the information from there. It's really up to, what people's preference is with respect to, whether they prefer to produce stuff in Markdown or editing. But does somebody want to take an action item to do something a little bit more specific in terms of aggregating some of the pain points and adding the documentation, or did Vish take that AR last time on himself?
I think he took it, but I'm not certain.
Okay. So if that's on Vish, then I don't see any polls against this, so I'll follow up with him.
I'd bank on me being wrong then.
Okay. Okay.
Jeremy, now that you're back, do you want to finish what you were saying?
Yeah.
Sorry, I think my Zoom crashed. I think what so we want to do it not just for TF serving. We have these other model servers, and we also want to do it for our batch jobs like TensorFlow. We'd like to have basic metrics like CPU memory. And I think one of the questions I have that's not clear to me is it better to sort of, for like the RPC, should we try to get them directly from like the gRPC server or TensorFlow serving? Or should we try to come up with like a more general solution that might rely on like an Envoy proxy, which you probably want anyway for like things like Istio to do it? And so understanding like what the best practices there are. And then similarly, it's not clear to me what the best dashboarding and way to surface these metrics is yet, whether we should be using like an in-cluster solution, sort of relying on cluster, back cloud and distribution specific backends. I don't know what like the best practices are. And so the more that we can have like the community Kubernetes tell us like what the best practices are, and then we can just kind of follow them, that'd be great in my opinion.
So, I mean, I think it depends on what for serving in particular, it depends on exactly what you've got up there. With TF serving, it's kind of opaque. If you're serving off a CPU, you can get CPU metrics, and in theory, scaling directly off of like CPU metrics, if you want to do auto scaling, should work. If you're doing GPU, we still don't have a lot there, right?
I thought Vish added utilization and duty cycle and some of the others for GPU.
Yeah, but is that sufficient to actually trigger the scaling? I don't know if that's actually in, by the way, either.
So I don't even. So at this point, we're not even at.
You're just looking at getting the hardware monitoring off.
Yeah.
Okay. So yeah, that's okay. So if you're just looking at getting telemetry from the hardware itself.
Yeah, so getting some indication, like, are you running effectively? Are you not running efficiently? And not even at auto scaling yet.
Okay. So then I was thinking of the proxy in terms of, are you looking at the proxy in terms of doing stuff like mixing? Or
for the proxying, we were looking at things like RPC metrics. So RPC counts, rates, and errors and latency. Those are the ones we want. And so ideally, it would be great if gRPC sort of exported those, or TensorFlow serving exported those automatically. But I think me and you talked about this in the past, and from what I recall of our conversation, it doesn't happen that way today. And
it doesn't happen that way today, and I've seen no motion from their teams in order to actually make that happen.
Yeah, and from what I can tell, what you also told me was it seems like it's non-trivial to do it either. So
it would be well. The best way to do it would be to get it from the gRPC layer. If we're talking about gRPC specifically, I mean, like it's not like brain surgery to get it out, but not like something that I'm going to have the time to go do a PR to get myself. Yeah. Well, so if you're looking at doing auto scaling, or if you're looking at telemetry, another way to do it would be to just use, if you put a proxy in front of it, extract all of it with the exception of the actual hardware telemetry directly from the proxy.
Yeah. So I think
you're auto scaling off of that too, if you wanted to.
Yeah. I think I'm leaning towards the proxy solution, mainly because it seems like we get the most bang for the buck. And I think integrating with Istio to do centralized policy management is something that we want to do anyway. So I don't know the details. That's not an area of my expertise, but my expectation is that once you're using Istio, you also need an Envoy proxy. And so it seems like that all fits together nicely, but the details elude me.
So I don't know, like I could take a look more into how Istio would help with this use case. I think Envoy does provide you with some of the primitives that you could use to achieve the type of proxying we're talking about. I don't know if it's
No, sorry. So we're not specifically looking at Istio for the metrics, but we're going to look at Istio for centralized policy management and security.
Oh,
So,
security?
well, security in the like mutual zero, what's the term?
Zero
Like,
trust, M off.
yeah. But so my main point was that if you're going to be doing, if you plan on moving in the direction of Istio, you're going to have an envoy proxy in front of everything anyway. So it's not like we're introducing an envoy proxy just for metrics or therefore incurring latency and other, I guess, other issues just for the metrics. That was my
Yeah.
point.
I mean, honestly, in most data centers, the single network hop you pay for the proxy is probably not going to be the bottleneck if you're talking about prediction serving, right? So that's probably not too much to pay. If you're using Envoy to do it, it's pretty cheap. It's a pretty cheap hop anyway. So I was thinking more in terms of doing this at the application layer and just having an application that sat in front of it if it was something people were interested in. I think the hard part to get my head around is like, I know TF serving model server to some extent. XGBoost I've played with a little bit, but there just seems like there's such a large collection of potential frameworks that would have to be supported in order to have a unified solution that works for everybody. And then each of those frameworks takes a different, not even necessarily just a different type of input from the application layer or the transport layer. Well, most transport layers are the same, but the like XGBoost is structured, for instance, right? I mean, like it's not the same. Like I don't know what a unified proxy that works for both of those looks like.
Well, so most of the servers they have this. So like we use Seldon. That's what our current solution is for. But it works for TensorFlow serving and TensorFlow models, but we are primarily looking at it for non-TensorFlow models. And basically, they all use the same API regardless of what model your framework you're using. And you basically just write a little hook that converts like the general request, which is usually like a list of arrays or some other sort of generic payload to your particular format for your model and whatnot. So there certainly is a layer there that you can sort of at the application layer where you can sort of interject logic that would apply across large framework of models, right? So there's really sort of only two. There's like TensorFlow serving, and then you have a model server for Python models. And I guess there are some other frameworks for like Onyx models and some of the non-TensorFlow, non-Python frameworks out there as well.
Yeah.
So anyways, that's very helpful. Thank you.
Okay. So
is there interest in doing essentially request batching for better throughput under certain latency budgets at the proxy level? I know this is kind of a direction that the Rise Lab at Berkeley with the Clipper project, but it seems like that naturally kind of fits into the Envoy Istio service mesh layer.
Sorry, my audio cut out. Can you repeat that?
Right. So has anyone heard of interest at essentially another feature at the service mesh layer for machine learning inference would be kind of request batching to increase throughput while maintaining a certain latency SLO. And there's kind of academic projects like Rise Lab's Clipper, which are designed to do this, but it seems to fit pretty naturally in an existing service mesh like Istio or Envoy, rather than having a separate project to do this, bespoke. And I was wondering if, Jeremy, have you heard of interest at this in kind of your discussions? I don't know if this is something of interest.
Yeah, so where we hear a lot about batching is actually with inference for GPUs in sort of a serving setting, because with GPUs, you really need to batch in order to batch multiple requests to get high throughput, and sort of manage latency. You can't process them sequentially. So that's the use case I've heard of most where this has come up. And one thing that's been mentioned is, I guess NVIDIA has I forget what it's called. It's like RPC. Maybe it's GPC. But anyways, they've got some library that's supposed to be able to effectively batch requests and stream things to the GPU in order to keep them well fed. Although I don't think it's not. I don't think it has a blocker. There are some technical details there that I'm not familiar with right now, but that's what I've heard of.
So is the optimization that you're looking for batching the memory that you're moving across from RAM into GDDR across PCIe 16 primarily?
I think the problem is if you I think the problem is that you need to process multiple requests together to get the efficiencies of the GPU. So if you just process the request as soon as it came in, while that request is processing, it's blocking all the other requests. It's not like multi-threaded. So if you have requests coming in every millisecond, right? You get better performance if you actually wait 10 milliseconds, aggregate all those requests, then process them all at once.
So it's utilization of the silicon. Before you spin a warp up, you want to have as much as you want to already have moved as much memory as you can onto GDDR before you spin the warp up in order to utilize the entire chip.
Yeah, I think that's accurate. I'm not sure about the exact, under the hood, but essentially, the whole point of the GPU is that it's high throughput because you can process multiple requests in parallel simultaneously.
Yeah.
But so you need to have multiple requests, otherwise you're not going to get high throughput.
So for Istio or Envoy, I think that would be very challenging for them to handle at that level because they basically have to intercept every request going through the entire cluster once you've enabled the service mesh network. And because of that, they try to be super lightweight in terms of touching their traffic. I don't know if they'd be – I could talk to them and see if they'd be willing to add a feature to do stuff like buffer a series of requests and then pass them back through. The other thing is I'm not entirely sure. I mean, they're HTTP aware for layer 7. I'm not sure how aware they are in terms of application level traffic. I know they do. I think they do gRPC, HTTP, and they will do certain things at the transport layer. I think UDP has some nation support, but not too much.
I honestly, at least my opinion, maybe GPU serving I think that's still very much an unknown. Whether that's actually the right thing to do or whether you're better off trying to serve efficiently from CPU, maybe compressing your model or doing some other approximation. So I don't know, at this time, that I would necessarily invest in trying to convince.
Right. Yeah, that was kind of my question. Is this how high of a fruit is this? And it sounds like it's pretty high. So I'm
not sure. That's what I'm saying. Maybe it doesn't hurt to ask. So I would think that this would be something that would be challenging for them, but we could always just reach out to them and say, hey, have you thought about request batching? Because there are definitely features that they do in terms of draining connections, circuit breaking, and so forth and so on. So there is definitely intelligence built into the proxy. Just a question of how much are they willing to do.
I think another angle on this too is if this is kind of the best practice for recommending that this is how we recommend you serve models using Istio and Envoy, then that's just more moving parts that kind of the smaller shops have to set up. So I think that's just underlines the kind of amount of the lift that is required for people to get up and running with these systems. So I think that's something to keep in mind as well.
Yeah. And then the other thing would be if you tried to batch your network, if ultimately you're trying to batch to serve the silicon, you'd have to make your network at that point aware of the silicon that it's trying to serve to, right? That doesn't seem like it's super awesome separation of concerns.
Normally the batch size is a pretty easily settable parameter of a model.
Yeah. I guess. But you'd basically be setting a network policy at, sort of a network policy up in order to make sure that requests are batched appropriately. Yeah, I don't know. It's something to think about because you could do the same thing at the application level. Whatever is receiving the request could just batch up a certain amount before it passes it on to whatever framework is actually interfacing with the GPU.
You do get into scenarios where you have pipelines of models. So you do sequential or parallel sets of inference for a given request. And so then you need more of a global awareness of what the total latency is for given batch sizes at each stage of the request.
True.
But then you're starting to get pretty esoteric. So,
but you could, so I mean, if you're getting the network latency out, it's more a question of where do you actually insert the batching logic, right? Like in terms of getting the network intelligence, Istio, Envoy, or a proxy, another type of proxy, is a good place to get that. But for the batching implementation, I don't know if you necessarily need to put that into the proxy as well. But yeah, we'll see.
Jeremy, you talked about the storage as well. What were you referring to there? Is this the kind of Kubernetes volume controller stuff that we've been working with you, or is this something else?
Oh, have you been working on the KVC? Oh, great.
Yeah, so I work with Balaji, and
fantastic.
Yeah.
So I think yeah, that's part of it. I think you know there's a question of like you know, if we recommend object store, you know, how do we get object stores that are, how do we come up with a good reference implementation for object stores that can run anywhere, and so that you're not just running on the clouds that have them, but you can also do it on-prem. And then I think there are use cases for shared POSIX, because you've got applications like HDF5 that require it. And so I guess shared POSIX is one of them, but I guess, you know, another potential solution is to use something like KVC and automatically sync data back and forth behind the scenes. But yeah, I think for us, we're just kind of trying to figure out at this point, you know, we've got some issues about like what are you know, the requirements and best practices that we can sort of recommend to people, so we can say like, okay, for examples and whatnot, we make use of a shared POSIX compliant file system. So on these types of clusters, or hey, it's distributions, go and provision NFS, and here's how you can do that. Or on, you know, this cloud provider, there is a, you know, cloud filer or solution already, so you can use that. Basically that sort of thing, so that, you know, in our solutions and examples, we don't sort of have to reinvent the wheel every time.
So it sounds like that's mostly kind of documentation and guidance in terms of pointing to existing object stores, and here's kind of a little bit of hand-holding in terms of setting these up if you haven't done so already.
Yeah, like, so I think, you know, as an example, you know, there's some discussion about like MinIO versus Rook.
Right.
And, you know, like which one of those gives you more bang for the buck, like in terms of, you know, getting object store and shared NFS, and is it performant, and so what cases can you use for it? And so just coming up with like good recommendations, so that, you know, we're not just telling people like, okay, here's a list of options, go and figure it out yourself.
Mm-hmm.
NFS is super challenging for a lot of people unless you already have something set up on-prem. Or for Amazon, they have, you know, Elastic File System isn't that hard to interface with. But getting something set up inside of a Kubernetes cluster, we could come up with some basic stuff to like maybe a Helm chart or something that would just install a couple of pods running some type of filer that would get you up and running for like demo purposes. Coming up with something that's robust and scalable would be challenging though. For object storage, I think the biggest problem I've seen, because like, most people I see want to use the S3 interface for their object storage. Like GCS, for instance, has an S3 compatible interface. Azure Blob Store does. There are a lot of EMC appliances that you can get off the shelf that have it. The biggest incompatible portion I've seen for that is the authentication credentials differ from provider to provider, and they might not even use the same type of authentication. So what works in one place isn't necessarily portable, even if you've used this S3 compliant API. I don't, like, other than coming up with a friction log about like for this provider, this is how you use it. This provider, this is how you use it. For Rook, if you're turning up Ceph clusters, that's a somewhat S3 compatible API. They have their own semantic differences there, but we could come up with something like, if you're using this one, here's what you should be aware of, I guess.
Yeah, I think we're iterating on all that ourselves, and I think the way I think we want this. I don't think we sort of understand the requirements yet either. So like to what extent is NFS needed and whatnot. It's proved convenient for a couple things, and we do have some use cases. But so I think that's where we're going to just learn over more time as we have sort of these examples running in cluster, and we get more feedback from the customers, and we see what solutions work and don't work and what the problems are.
I think one thing to simplify the problem is that, in my experience, the storage solution you need on your cluster often doesn't have to have the resiliency or robustness guarantees that you were used to with storage providers, because these kind of clusters tend to be more of the kind of computation domain. I mean, this doesn't hold in all cases, but so what I mean is some grad student lab will have their NFS box, but then they have a separate cluster that's the compute cluster. And so you just want to get the data in a format that's closer and more scalable, but you don't necessarily need the robustness because it's a second copy of the data. That doesn't always hold, but that does vastly simplify the problem in terms of making it not have to be highly available and fault tolerant and all these kind of things.
That's interesting. Okay, does anyone have any other topics they'd like to discuss? Okay. I don't really have anything else either. Do we want to end early and take back 15 minutes then?
Might as well.
Okay. But before we go, I want to discuss, does anybody have anything specific that they want to add to the working group repository between now and the next 2 weeks? I know Vish definitely wanted to capture some things. Jeremy, did you want to capture some of the feedback that you just gave in terms of potentially at least outlining what we might do for storage and proxying multiple models?
Yeah, we have most of that is covered in GitHub issues within the Kubeflow. Okay. So I just assume leave that information there and use that as the source of truth for us.
Okay. Well, that makes sense. All right, I want to propose something else. Generally, at least in SIG-Apps, what we usually do before the meeting is come up kind of with the topics that we want to discuss prior to the meeting starting. So if anybody for the next, which is what, April, yeah. So if anyone for the next meeting wants to propose a topic that they'd like to discuss in particular, feel free to access the doc and just throw it on there, and we can go from there. Unless people aren't amenable to that type of structure.
That sounds good to me.
Okay. All right, cool. All right, guys, I'll see you in 2 weeks then.
Thanks. Bye.
Thanks.
Bye.